Okay. The topic which we are going to see in this session is total probability and Bayes theorem. Okay. But before proceeding with total probability and Bayes theorem, we have to be clear with the conditional probability. What is conditional probability? See the definition and say P of A given B is P of A intersection B divided by P of B, or else P of B given A, that is P of A intersection B by P of B. Either way we will write. So this concept and all wherever we use, wherever required that place we will use, but we have to be clear with what is this conditional probability concept. See, whatever comes in the denominator that happens first, then whatever comes in the numerator that happens second. Okay. So when we mention this, A already happened, after that B is happening. Okay. So with this understanding, we'll see what is total probability. The total probability means we'll take some events A1, A2 up to A, certain events. Okay. These events are mutually exclusive and exhaustive. Meaning what? Meaning these events are filled to the sample space A1, A2, likewise up to A. When you union all these events, you will get the whole sample space S. Okay. Now, these n events we are having, in that let A be any event that related with or else in connection with some AK. Some AK means some A1, A2, A3, A4 like this, some certain number of events. Okay. Then P of A, happening of the event A that is in connection with some K events particularly. Okay. Then summation I sigma notation I is equal to 1 to n P of AI, after that P of A given AI. Meaning what? Probability of that particular event happening into after the happening of A1, A is happening, plus probability of a particular event A2 is happening, after the happening of A2, A is happening. Likewise, you may not understand this like exhaustive, exclusive and all. Take this scenario for example. We have 3 boxes. Box 1, box 2, box 3. Okay. In that certain number of white balls, for example 5 white, here 3 white, here 4 white balls. So here 2 black, 7 black, here 5 black, likewise randomly I am choosing. Now from all the 3 boxes, choosing a ball from any one of the box. Choosing a ball from any one of the box, what is the probability that it is a white ball? How we will calculate? First we should understand which box we are choosing. Okay, that may be from first ball, that may be from first box, second box or third box. So before choosing white ball, we are choosing the box. Okay, that is what A1, A2, A3 here. Then what is A? That A is choosing a white ball. Okay. So the probability of choosing the first box into, after choosing the first box, in the first box white ball coming. So when I mention P of A1 into P of A given A1, meaning what? The probability of choosing the first box into probability of A given A1 means after choosing A1, what is the probability of getting a white ball from that? Okay, clear? Are you clear with this? Okay. This A1, A2, AK and all, you don't need to bother. So likewise, these all the events, like choosing 3 boxes, are equally likely. Choosing first box, probability 1 by 3, second box, probability 1 by 3, third box also 1 by 3. So this is how the total probability works. Any doubts in this? I am telling you once again, see, the total probability, that is, there are n events. Those are mutually exclusive and exhaustive, that fills the sample space, and the event A that is in connection with some AK, like any one of the A1, A2, A3. In this, A1 also disconnected, A2 also disconnected, A3 also disconnected. Okay. Then the total probability of getting a white ball, sigma notation. Sigma notation means what? Probability of choosing A1 into probability of choosing A given A1. Likewise, plus probability of probability of choosing A2 and the probability of A given A2. Then up to which number we have to write? 1, 2 already written, then up to 3. Okay. Any doubts in this? Okay. Now we are going to extend this one to another extent. They actually, this A given A1, P of A into and all are part of multiplication theorem. Don't you see it? So it is nothing but, don't get confused if you can't understand. A1 intersection A, common between the two. Then by multiplication theorem we can write in this form. Okay. Likewise, probability of A2 intersection B. Then by multiplication theorem we can write in this form. That is why in the first place I asked you what is multiplication theorem, what is conditional probability, everything. Okay. Clear? So that is total probability. And as an extension of this total probability, one person BAYE, the person name is BAYE, he derived one theorem. Okay, that theorem states that P of AK given A equals P of AK into P of A given AK divided by P of A1. Why can't we go with this summation I is equal to 1, P of AI, P of A given A. I am sure that you can't understand anything in this. See, here we calculated total probability, that is written in this form. Okay. So here what I used? Total probability. So here downstairs what is there? That is total probability. And this one surely particular case about anyone. Okay. So this is favorable. Favorable by total. That is what? Probability of an event. Favorable outcomes divided by total number of outcomes. So that is the basic concept in this Bayes theorem. Now let me explain you with this one in this example itself. See, previously we have calculated what is the probability of getting white ball. That is P of A, total probability. Suppose in the question itself they asked what is the probability of getting a white ball from second box? Second box, meaning what? They defined where it should come. So, favorable. How many favorable second boxes are there? Second box, man. How many second boxes are there? Only one second box. But we are not sure which box we will choose. Okay. So, the total probability for this, that is P of A. P of A means, here I am mentioning total probability, all the A1, A2, A3. And in the numerator, P of A2, P of A given A2. That's all. In short, what I can say about total probability and Bayes theorem is, if there are certain boxes or certain urns in a theoretical manner, certain events, one single event is associated with any one of this, or some events in this. The probability of happening of that particular event, if you want to calculate, means we can calculate total probability. In which box, in which urn it is happening, like they mentioned, means in that case we have to use Bayes theorem. That is the whole difference. Okay. Likewise, we will see many questions. In that case, I will explain you in more detail. So, you should get this idea first of all, whether they mentioned any particular thing or not. If they mentioned means, we will use Bayes theorem. If they didn't mention means, we will use total probability. Okay, clear? Now, one more time you say, if nothing mentioned, only happening of the event, what we have to calculate? Total probability. Okay. Suppose a particular place or a particular box is mentioned, then Bayes theorem. Okay. What is the difference between the total probability and Bayes theorem? Total probability will add everything, whereas in the Bayes theorem we'll add everything, right? In that some particular event only we need, that one will take to numerator. That is all. Clear? In this case we have A1, A2, A3, but as per the question I asked, here A2 comes to the numerator, remaining everything comes down. Suppose if I mentioned box 3, the ball should come from box 3, then divided by P of A means P of A1 into P of A given A1 plus P of A2 into P of A given A2 plus P of A3 into P of A given A3. Clear? Shall we proceed with the questions? Okay. Yeah, write this formula. Which formula you want? This one? Okay. Write fast.